Hi there, folks. Today we're looking at an introduction to equations. And an equation here is a mathematical sentence that uses an equal sign. And that's the subtle difference between an equation and an expression. Remember, an expression does not have an equal sign, all right? But an equation has an equal sign in it, all right? And with expressions, we had numeric and algebraic expressions. With equations, we either have equations that are true, false, or open, all right? And really, a true equation just means that when we simplify the expression on each side of the equation, so when we simplify what's on each side of the equal sign, we get two things that are actually equal to each other. All right, so if we get a true statement, this thing equals this thing, 5 equals 5, then we say it's a true equation. All right, it's false if after simplifying the expressions on each side, I don't get the same thing on each side of the equal sign. All right, if I end up with 4 equals 7, then it's false. It's an equation that wasn't true because I didn't get the same thing on each side of the equal sign. All right. And it's open if, frankly, we can't tell if the two sides are going to be equal, all right? And typically this happens when there's a variable thrown in there, right? I mean, if there's numbers thrown in there, we know we can simplify. But if there's a variable thrown in there, I can only simplify so far before I can't necessarily say whether the two sides are equal, okay? Because it depends on what the variable is, all right? And what we'll end up doing at some point here is we'll replace the variables with numbers to see if they're true or false. So we'll convert from an open expression into either a true or a false, an open equation to a true or a false equation. And that's very similar to what we did with expressions. Remember, we had algebraic and numeric expressions, but the algebraic expressions we would substitute in for the variables to then convert it to a numeric expression that we can simplify. And this is the same kind of thing is going to happen here, okay? For example, just looking at these real quickly, let's decide if each equation is true, false, or open. And again, these are equations because there's equal signs. So basically, I have an expression on each side, all right? So let's simplify each expression. So this one, the first side, the first expression over here says 32 divided by 8, and 32 divided by 8 is a 4. And then the second expression over here says 2 times 3, and 2 times 3 is a 6. And since 6, that is not the color I wanted. Since 6 does not equal a 4, this is not true. So I'm going to put a little slash through the equal sign because 4 does not equal 6. I can say that this is a false equation, all right? It's false because the two sides do not equal one another, all right? So this one is false. If I look at the next one I could try simplifying, but here 3y plus 6, I'm not allowed to add those together because one's a y and one's a number, all right? It doesn't work that way. And so there's nothing I can really do to simplify this. I can't tell if these two sides are equal because I don't know the value for y. See, if I had a value for y, I'd be able to simplify, come up with a number, and see if these are equal. But as it stands, I can't tell whether or not these are going to be equal, all right? So this is an open equation. It's open because I don't yet know if this thing is going to be a true or false. I would need more information. I would need a y value to test, to plug into this thing to see if this is true or false, okay? And then the last one here, again, simplify each side. The first side of the equation says 16 minus 7, and 16 minus 7 is a 9. The second side of the equation says 4 plus 5, and 4 plus 5 is a 9. And so I have 9 equals 9. Well, 9 does equal 9. That's a true statement. So this is a true equation. Okay? And so what we do here is we want to start looking for solutions. When we look at that one in the middle, the open equation, we want to figure out what y value makes it a true equation. Because there are plenty of y values that I could plug into that open equation that would make it a false equation. I'm looking for the y value that makes it a true equation, okay? And we call that the solution of the equation, all right? We're going to do that through just testing some points, that kind of stuff, and then going from there. So the solution of an equation is a value for the variable that makes the equation true, all right? Essentially, when we replace the variable, it becomes either a true or a false equation instead of an open equation. We're looking for the value that makes it a true equation, all right? And one of the big foundations for algebra, guys, is just plugging stuff in for variables, all right? If you can plug in and do order of operations, that is huge, all right? That is a skill that comes up a lot in algebra, okay? For example, if I look at some of this guy, I've got 32 equals 2x plus 12. That is an open equation. I don't know if it's true or false yet, but it gives me an x value to try. It says, hey, try the x value of 6. And remember, whenever you plug things into an equation, use parentheses to plug it in. So I surround that 6 in parentheses. And now I follow order of operations. See, the 32, that's already simplified. I can't do anything over there. But on the other side, I have multiplication and addition. Order of operations, I do the multiplication first. So that's a 12. Next, I do the addition, which gives me a 24. And now I have a statement that says 32 equals 24. That is a false equation. These are not equal to one another. This is a false equation. And what that tells me, it tells me that x equals 6 is not a solution. Okay? So determine if x equals 6 is a solution. The answer is no. Okay? X equals 6 is not a solution. Okay? And it's not a solution because when I plug it in, I get a false equation. All right? If I look at the next one, again, this is an open equation right now, but I'm going to convert it to either a true or a false equation by substituting in. So here, it asks me to plug a 1/2 in. Again, use parentheses to plug things in. And here I have 6 times 1/2. Remember, multiplying by a fraction is like, what is the fraction? So when I say 6 times 1/2, I'm saying, what is half of 6? We tend to have a lot of trouble multiplying fractions because we don't think of them more holistically. 6 times 1/2. And here's the thing. The other thing about fractions, that's like times 1 divided by 2. So 6 divided by 2, it's a 3. Okay? So work on those fractions. And now 3 minus 8 is a -5. So here I have a true statement, -5 equals -5. This is now a true equation. Since it's a true equation, it means that m equals 1/2 is a solution. And it's a solution because when I plugged it in, the equation went from being an open equation to a true equation. Okay? How about this one? It says, which of the following are a solution to the equation 2 times x plus 3 equals 3 times x plus 2 minus x? And again, I just need to plug in and simplify, all right? So plug it in, and again, plug it in using parentheses. Always a good idea. It doesn't always make a difference whether or not you use the parentheses, and this one's not going to matter, but it doesn't hurt anything to use the parentheses, okay? So when I plug this guy in, inside these parentheses, I do the addition. Over here inside the parentheses, I also do the addition. And now I have some multiplication to do. Let me expand this a little bit. I ran out of room on my paper, so I just made the paper bigger. I'm like a sorcerer. It's amazing. And now here I do the subtraction. Again, I'm following order of operations on each side. Whoops, I forgot to do the subtraction. So I get a 10. So that gives me a true statement, which means this guy works as a solution. Okay? But now let's try the next one. And here's the thing. A lot of equations that we have will only have one solution, but sometimes you can have more than one. Sometimes more than one value works. Sometimes only one value works, okay? And we'll learn to tell the difference between those kind of things as we get further and further into this. But let's try the next one. Again, I'll use parentheses to plug it in. And now I start to simplify. Over here inside the parentheses, I do the addition. Over here inside the parentheses, I do the addition. That gives me a 0. That's interesting. And here, I'm going to change minus a negative. That's the same as adding the opposite. Remember, anytime you're subtracting, you can change it to adding the opposite, so that becomes a +2. And so now here I get a 2 equals 0 plus 2. I do that multiplication first. Now I do the addition. 2 equals 2. That is a true statement, which means I found another solution. Okay? So again, let me wipe the slate clean here. Let's go again. Let's plug the 5 in. Again, I always use parentheses. Doesn't hurt to use the parentheses. Sometimes they don't really make a difference, but you should always be in the habit of using parentheses to plug things in. It's a great idea. It will save you in the long run, I promise. So here I start inside the parentheses. That gives me an 8. Over here I start inside the parentheses. That gives me a 7. Now I do multiplication. And now on the right-hand side I do the subtraction. Oh, look at that. 16 equals 16. I get another true statement, so there's another solution. All right, last one. Let's plug it in. And if nothing else, this is really good practice doing order of operations. But plugging things in, man, this is a huge skill. If you can plug stuff into an equation, you can do a lot of things in math. Okay, so practice plugging things in. It's really, really important. All right. And so here I start inside the parentheses, order of operations. That gives me a -1. Over here inside the parentheses, that gives me a -2. Once again, I have minus and negative. Let's change it to adding the opposite. Okay, so you change each of those signs so it becomes plus a positive, so +4. Now I do the multiplication. Here I do the multiplication. And now let's do that addition. So I get a -2. -2 equals -2, another true statement, so another solution. So all of these happen to be a solution for the equation, okay? And so again, with equations, sometimes we only have one solution, but sometimes we have more than one solution, all right? And if you haven't guessed it by now, when you think about this thing, if you remember how to simplify some of these guys, okay? And this is not something you necessarily have to be able to do yet, but over here, if you remember how to simplify this guy, by using the distributive property, which we will do at some point. And this guy, which is a 3x plus 6. And now if you remember combining like terms, the 3x and the minus x is a 2x plus 6. Notice I have the same thing on each side even though I have variables. 2x plus 6 equals 2x plus 6. So wouldn't every x value, no matter what I pick, work? Because they're equal to each other even before I replace the x, okay? And so that's kind of what happens here. But again, just plugging things in and testing to see if I get a true statement, all right? If I look at this guy, a rectangle has a length that is 2.4 times the width. If a student makes the length of the rectangle 54 inches, which of the following widths would be used? And so for this one, it says right here, the length is, so the length equals, okay, that's kind of what is translates into as an equal sign, 2.4 times the width. So 2.4 times W, all right? And so it says, what if I make the length 54? So this is the open equation I'm dealing with. All right? And I just have to plug some of these in and check them. And you can use a calculator for this. That's fine. But plug the 2.4 in there. Plug the first one, the 2.4 in there and see what you get. So if I do 2.4 times the 2.4, I get a 5. Actually, let me scoot this guy off to the side. So I can actually show it. Always good to show things, right? So I've got 54 equals 2.4 times W. I replace that with the 2.4. And when I do the 2.4 times the 2.4, I get 5.76. That is false. So this one doesn't work. I can eliminate that answer. And now I jump on to the next one. I say 54 equals 2.4 times 11.25. Notice my use of parentheses again. And I simplify 2.4 times 11.25, and I get 27. And so 27, that does not work. So this one isn't true either. And I move on to the next one. Kind of running out of space here. Let me scoot these over a little bit. So again, I'm just plugging them in to see which one of these gives me a true equation. Right now I have open equations. I'm looking for the true equation. Again, use parentheses to plug it in. And so this one, I do 2.4 times the 22.5 on my calculator. And look at that, I get a 54. So this one gives me a true statement. This is my answer. And I can check the last one, although you're probably looking at it, hopefully you're suspicious, thinking there's no way that's going to work because 129.6 is already bigger than 54. So if I multiply that by 2.4, isn't it going to get even bigger? All right, so I don't really need to plug this in. All right, use a little bit of logic to determine, hey, there's no way that's going to work. If you want to plug it in, here's what you get. 311.04, not even close, okay? So that gives me a false statement. That does not equal that guy. So the only answer this time is the 22.5, all right? And so just to give you an idea, here's an equation where, guess what? That is literally the only solution that will work here. There is no other number in the universe that will work to answer this question, as opposed to the last one where every number seemed to work, okay? So there could be one solution, there could be multiple solutions, all right? So now these guys, let's think about this just using some mental math and just thinking about addition and division and multiplication, that kind of stuff. If I had x plus 8, something plus 8, what would that something have to be? And hopefully you're thinking about it in your mind. You're saying, well, I know that 4 plus 8 equals a 12, so x has to equal a 4, okay? And now think about the operations that kind of relate these things. See, 4 plus 8 equals a 12, but doesn't 12 minus 8 equals a 4? And so we want to kind of start to think of this in elementary school. I think they called them fact families, but we want to think about that kind of stuff. You know, we know that 4 plus 8 equals a 12, but we also know that 12 minus 8 equals a 4. Okay? And so we start to think about that relationship between addition and subtraction, and that'll help us solve things later, all right? This one, something divided by 8 equals 9. Well, I know that 72 divided by 8 equals 9. And again, it's that idea of a fact family. We say, hey, 72 divided by 8 is a 9 because, thinking about it the other way, 9 times 8 equals a 72, okay? So think about that relationship between multiplication and division. This one, I have 12 minus something equals 3. Well, 12 minus 9 equals 3, so y would have to equal a 9. But again, think about it this way. 12 minus 9 equals 3. And part of that is because, 9 plus 3 equals a 12, okay? Or you could also think about the relationship between, 12 minus 3 equals the 9, all right? So think about those operations in terms of addition and subtraction, how they're related, okay? And then this last one, again, just using an XY type of chart here, this time it's N, but we're just going to make a table of values, all right? This will become an XY chart as we move further and further into the course, all right? But it's the idea of taking values, plugging them into an equation, and getting other values, all right? This is huge in math, all right? But here I have the equation 5n plus 8 equals a 48, all right? And it says to make a table of values, I'm going to discover which n value works to give me the 48, but I'm also going to practice my order of operations as I go. So here, it's just saying, hey, plug a 5 in for n and see what you get. So again, use those parentheses. Now let's do a little mental math. 5 times 5 is 25, plus 8 is a 33. And now it asks me to plug a 6 in. And I'm just doing order of operations, albeit I'm doing the 2 steps in my head. Ready? 5 times 6 is 30. 30 plus 8 is 38. And now I plug a 7 in. 5 times 7 is 35. 35 plus 8 is a 43. And now I plug an 8 in. Look at my use of parentheses as I plug things in. Order of operations, I do the multiplication, then the addition. 5 times 8 is 40. 40 plus 8 is 48. And that kind of answers the question, but let's keep going anyway. I'm going to plug the 9 in. 5 times 9 is 45, plus 8 is a 53. And then the last one, 5 times 10 is 50, plus 8 is a 58. But the idea here, the idea of plugging a bunch of values in and coming up with the new values here, the idea of using a table is huge in mathematics, okay? Make sure you're good with plugging things in for a variable and simplifying, all right? Very important skill. But now to answer the question, we wanted this thing to equal a 48 right here. And so I go down here and say, okay, which of these equaled the 48? Well, it was this row right here. And so can you see the n value that solves this particular equation? N equals 8, all right? But now because I have that table of values, what if I asked, hey, which number for n would make the equation equal a 58? Well, now I know it's a 10, okay? And so I can see that table of values. I can see all the n values that would make certain things true if I changed what this was equal to, okay?